Today we will learn about the slacks and floats in a network. So it's a part of network analysis, project management, the techniques that we are going to discuss the PERT and CPM. So in this thing, so a portion is the slacks and float. So slack and float, if I want to have a understanding about the slack and float, it's nothing but the free time. Okay, suppose if I want to complete an activity, so my deadline is today 5 p.m. and I can start my activity from 9 p.m. onwards. The activity takes at least 5 hours to complete. 5 hours to complete, let it be. So in those cases, if I start by 9 o'clock, I can finish my activity by 2 o'clock. So rest of the just 3 hours, I will be free. But if I'm starting by 10 o'clock, I can only finish by 3 o'clock, right? And if I start by late, even 11 o'clock, I can finish by 4. And the maximum delayed time I can start is 5 o'clock, 12 o'clock, so that I can finish by 5 o'clock. So this 3 hours is there, but it will depend on whether I am starting early or whether I am starting late, which dictates which hour I will be free, right? For an activity which is not coming under the critical path, similar free time or float is there. So our objective is to understand what are they and how can we calculate the floats. So in this, suppose in this example for the activity C, which is the activity starting node is 2 and the ending node is 3. In this case, we can see that the total float is nothing but the LF, the latest finishing time, minus earliest finishing time, or latest starting time minus earliest starting time. The dotted line, the solid line and dotted line is there. So the dotted line shows the float that we have, right? Here also it will be the same. Otherwise, we can use the formula LF, the latest finishing time, minus earliest starting time minus P. Still, you will get the same answer as float. Okay. Now this is known as total float. Now there are other floats. Now a term is there which is known as slack. Slack is defined for activities. So slack is designed for nodes or the events. Okay. So head event slack means, suppose this is the activity C, the head event is 3. So whatever difference in coming in the head event, suppose the earliest finishing time for this activity C is 9, and the latest finishing time for this activity is 12. So the difference between this 9 and 12 and 9 is the slack, head event slack. Similarly, for the same activity, 2 is the tail event, and the earliest starting time for this activity is 5, and latest starting time is 8. So the difference is 3. So which is also known as the tail event slack. Okay, slack is also the difference between earliest and the latest time, right? Latest, or you can subtract latest minus earliest will give you the slack. If it is for the tail event, it will give you the tail event slack. If it is for a head event, we will get the head event slack. Now we will learn about how we can calculate the floats and what kind of floats we are interested. Okay. So let's understanding this with an example. So here is a small network is given. So we are going to estimate the earliest times and the floats. Okay. So earliest times are being computed in the forward passing. So forward passing means, suppose we are starting from this node. So this is the starting node of the project, and 6 is the finishing node of the project. So in this one, so what early I can start? So that will give you the earliest starting time. So in the blue box, I will write down the earliest starting time, and in the green box, I will earliest times. In the green, I will write the latest times. So whether it's starting or ending will check whether it's the starting node or the ending node. Okay, earliest starting time or latest finishing time. So earliest and the latest, I will give you in these boxes. And also you can, whatever I have given, this boxes is for these nodes, not for the activity. If I want to calculate for the activity with the whatever we have in the boxes, we have to use those things to estimate the earliest finishing time or latest finishing time or force for the activity. So let's fill up this thing. So for the first activity, I have means what early I can start is in the my 0th hour. So 0 will be the earliest starting time for this one. For this second activity, so how early I can start? Suppose this earliest I can start for the activity 1 for the event 1 is 0. So plus this duration will give you the earliest starting of this activity or this node. So this event to occur. Okay, so that will be 4. Earliest for this one will be 0 plus 3 will be 3. For 4, for this node 4, so that will be 2 plus 4, which will be 6. And for this 5, for the case of 5, there are 2 ways we can reach, right? Either 2 to 5 or 3 to 5 is there. So there is 2, this thing is there. So either it will be 7 plus 4, 11, or 6 plus 3, 9. So which one will it take? We will take the maximum. Why? Because if I want to, this is the starting node for activity this 5, 6, right? Suppose if I want to start the activity 5, 6, my 2, 5 and 3, 5 has to complete. So my 2, 5, 3, 5 will complete by 9, but my 2, 5 will complete only by 11. So in the forward passing, we will take, that's why in the forward passing, we will take the maximum value. So 4 plus 7, it will be 11, right? For 6 also, there is a clash. So either it will be 6 plus 4, 10, or 11 plus 2, 13. So we will take the maximum one, 11 plus 2, which is 13. Okay. Now this is not a forward passing. So whatever values that we get is the earliest times. Now we have to find out the latest time. For that, we will take the earliest time for the final node as same as that of the latest finishing time of the final node. So 13, latest time will put as 13. So and this will also give you the project length, project duration, or the length of the critical path will also be the same. So it will be 13 hours or 13 weeks or whatever units be in the time we take. Now we will start the backward passing from the end finishing node. So we will go backwards. So 13 minus 4 will give you 9. 9 will be the, for this fourth node, it will be 9. So this fifth node, this 13 minus 2 will be 11. For this node 2, there are 2 possibilities. Either it will be 9 minus 2, 7, or 11 minus 7, which will be 4. So which one will you take? In the backward passing, we will take the least value. So it will be 11 minus 7, which will be 4. For this 3, it will be 11 minus 6, which will be 5. And for the first activity, it will be 4 minus 4, 0, or 5 minus 3, 2. So the least we have to take, so that will be 0. So this is how we do the backward passing. So we get the earliest and latest values for individual nodes. Now we have to calculate the earliest and the latest times for the activities, for individual activity. For the activity 1, 2. So 1 will be the starting node and 2 will be the finishing node. Okay. So what will be the earliest time? Earliest time will be for the starting node. So what is the early time for the starting node? We have to put it here. So it will be 0. So 1, 3 also, for 1, 3 also, the starting node is 1. So the earliest time the 1 can happen is the 0th hour. So 2, 4. For the 2, 4, the starting node is 2, and the earliest time for that is 4, right? For 2, 5 also, the starting node is 2, so the earliest time is 4. For 3, 5, the starting node is 3, and the earliest time for that is 3. Similarly, for 4, 6, it will be 6, and 5, 6, it will be earliest starting time is 11. Okay, so we get the earliest starting times. Now, what will be the earliest finishing time? Finishing time will be just add the duration. So we are starting early plus the duration will give you the how early we can finish. So nothing but this column plus this column, right? So 0 plus 4, 4, 3, 6, 11, 9, 10, and 13. So this is how we estimate the earliest finishing times. Now, latest finishing time for that we have to compute, right? So it will start from the, or we can do it from this. This will be easy for you. So that for sixth node, it will be for 5, 6. 6 is the finishing node. So the latest time is 13. Now 4, 6 also, 6 is the finishing node, so it will be 13. 3, 5. 5 is the finishing node. So what will be the latest time for 5? Is 11. 2, 5 is also, 5 is the finishing node, 11. 2, 4. 4 is the finishing node. What is the latest time for that? That will be 9. 1, 3 is also 3 is the latest time. So means finishing node. So that will be 5. And 1, 2, 2 is the thing. So that is 4. Now, if I want to estimate the latest starting time, it is nothing but this latest finishing time minus duration. So you can subtract duration from this thing and you will get this. So let's do that thing. 4 minus 4, 0. 5 minus 3, 2. 9 minus 2, 7. 11 minus 7, 4. 11 minus 6, 5. 13 minus 4, 9. And 13 minus 2 will be 13 minus 2 will be 11, right? Now we know what is the head event slack, right? Suppose for this 1, 2 node, head event is 2, and the slack means this 4 minus 4. For this activity 2, 4, what will be the head event will be 4, and the difference in the head event means the latest time and the earliest time. So that will be 9 minus 6, which will be 3. Like that we can fill it. So this is nothing but LF for the head event. It will be LS minus E. These two difference will give. So this will be basically latest finishing time minus earliest finishing time. So this subtraction will give you. So this will be 4 minus 4, 0. 3 minus 5 minus 3, 2. 9 minus, from here also you can do 2, 4. 4 is a node. So what is the head event? 9 minus 6, 3. So it will be 11 minus 11, 0. 11 minus 9, 2. 13 minus 10, 3. There is some mistake. So this is not earliest finishing time for this thing is 11. So okay, sorry, this will be 13 itself. Sorry, this is not. Actually, I made a mistake. So let's correct that mistake and let's do it from the 13. For the final node, we have made a mistake. This will be 11 only. Okay. This will be 13. So for the finishing node, it will be the same. Now 13 minus 13 will be 0. Okay. Now tail slacks. Tail slack means when it is 1, 2, the tail event is 1. So the slack in the tail event, that will be 0 minus 0, 0. For this one, 1, 3, it will be the same. 1 is the tail event. 2, 4, 2 is the tail event. So better you can write it from the figure itself. So 4 minus 4, 0. 2, 5 also 4 minus 4, 0. 3, 5. 3 is the tail event. So 5 minus 3, 2. For 4, 6. 4 is the tail event. 6 minus 9. 9 minus 6, 3. 5, 6, it will be 5. 11 minus 11, 0. Okay. So now we can calculate the total float. Total float equation that we have seen, it will be either LF minus L EF, earliest finishing time, or LS minus ES, or LF minus ES minus T. This will be the convenient formula for calculating the total float. It is for this one, it will be 4 minus 0, or 4 minus 0, or 4 minus 0 minus 4. Right. Now we can check whether, okay. Anyhow, we will use this formula for calculating the float. Okay. Better, that will be the convenient thing. Okay. This minus 0, or LF minus EF, that will be better, right? Here you can see it very easily. So this will be for 1, 1, 3, it will be 5 minus 3 minus 0, it will be 2. For 2, 4, it will be 9 minus 2 minus 4, this will be 3. For 2, 5, it will be 11 minus 7 minus 4, it will be 0. For 3, 5, it will be 11 minus 6 minus 3. 6 plus 3, 9, so 2. For 4, 6, it will be 13 minus 4 minus 6, 3, and this will be 0. 13 minus 2 minus 11. Okay. Now free float. So total float is defined as that part of the maximum float, or if all the activities is happening at its or all the predecessing activities happening at the earliest time, and all the succeeding activities happening at the latest time, then what will be the time frame that we have, so that even though that much activity is delayed, that much will not affect the critical path or the total completion project time. Okay, so that is how the total float is defined. Now free float is nothing but free float is equal to total float minus your head event slack. So this is defined as that part of total float which does not, which we have the flexibility without affecting the succeeding activity. Succeeding activity should not be affected. So the succeeding activity will start at the earliest time. So and whatever free time we have, if that is the case, whatever free time we have. So this equation you can use. So total float minus head event slack. So free float can be, this is total float, this is the head event slack, so 0. I think I have made some mistake in the head slack. This will be 0. 3, 5, 3, 5, which has, okay, sorry. This will be, and this 4, 6. Head event is so for 3, 5, the head event is 5, so 11 minus 11, 0. For 4, 6, the head event is 13, means 6, and 13 minus 13 is 0. Okay, so the free float, let's calculate. So this will be total float minus head slack, so 0. 2 minus 2, 0. 3 minus 3, 0. 0. This will be 2 minus 0. This will be 3 minus 0. And this will be 0. Now the independent float is nothing but the free time that we have if without affecting the early means predecessing activity or the succeeding activity. So what time frame we have? Okay, that will depend on the independent. So independent float can be find out. It's a part of free float only. Free float minus the tail slack will give you the independent float. Okay. So how can we calculate? So free float. This is the free float minus tail slack. Tail slack is only here. So it will be 0, 0, 0, 0, 2 minus 2, 0, 3 minus 3, 0, and 0. Okay. So interfering, so this is the independent float. There is a term sometimes seen that which is known as interfering float. Interfering float is nothing but our head event slack. Okay. So it will be same as head event slack. So it is the float which the delay of its delay will not start any means it can delay the starting of the predecessing or the following activity. Okay, of the non-critical this thing. So let's write that also. So this will be nothing but the head event slacks. This will be 0, 0, 0. No, this will be 2, and this will be 3. That's slack. Okay. Zero and 0. Okay. So these are the main three or four floats in a network.